Hey y'all, in today's video lesson, we're going to be learning about X and Y intercepts. We're going to be looking at how to find those on a graph, in an equation, maybe a table, all the different ways. Before we get into talking about X and Y intercepts, let's first review a point. So graphing a point. A point, we usually label it as X comma Y. You can use other variables, but typically speaking, we use X and Y. Is plotted on a coordinate plane, is what we call it. You might call it a graph, but its technical term is coordinate plane. A coordinate plane has an X and a Y axis. In this case, since I labeled the point as XY, my coordinate plane is going to have an X and Y axis. If I had labeled it A comma B, then it would have an A and B axis, but we'll just go with X and Y. These axes meet at the origin, which is the point 0, 0. So it's kind of the center, I guess you could call it. So in this first example, we're just going to practice plotting some points. And we have a set here, actually a relation. A relation is a set of points. So we have a set of points here, a relation, and we're just going to practice plotting those points. So if you're already familiar with plotting points, I want to encourage you to pause the video, plot them yourself, and come back and check. If you're not, then I'll explain it in just a second. So far, I've plotted some of the points, and you can see them on the coordinate plane. We've started with 0, 0, which is the origin, and that's the center. So that means that we're not going to the right or to the left, up or down any. We're just on the center. So what's happening here is, if you're unfamiliar, this is X and this is Y. And then this is X, the X axis, and this is the Y axis. So X is indicating how far you're going to the right or to the left. Right or left. And Y is indicating up or down. So Y is going to be the vertical axis, and X is going to be the horizontal axis. And the reason why I say that is because sometimes they might say, what's the horizontal intercept or vertical intercept? And so you got to know what that is. So we always start with X when we're plotting points. So that means we're going to some people say walk into the building. So you walk into the building and you're going to go left or right, and then you hop on the elevator and you go up or down. So that's X comma Y. So you can see here I have some of the points plotted. -4 means we go left 4. +1 means we go up 1. So we walk in the door, that's the origin. We turn left, we go down the hallway 4 feet, whatever, I don't know, and then up the elevator 1 floor. Okay, 4, -1 means we go right 4, down 1. 4, 1 means we go right 4, up 1. And then -4 means we go left 4, down 1. And that's where we put our point. And you can label these if you want to. Sometimes they will have like a capital letter to label the point. So you could do that if you wanted to help for your notes. A, B, C, D, E, and then label them. This is point A, point B, and so on. So that's plotting points, a nice little review before we get into the lesson. We're going to talk about X and Y intercepts today. So for an X intercept, that means it crosses the X axis, which if we look at a coordinate plane, for something to cross the X axis, that means it has no up or down. We're kind of on the ground floor. We're not going up in the elevator or down in the elevator. And that means that the Y value, since there is no height, no up or down, that means that the Y value has to be 0. And that's not just for linear functions, that's for any function. So as we go through all of the lessons in the semester and all of the units, you're going to be finding X and Y intercepts forever. So you can't wipe it from your memory. You got to keep it in there. So for the rest of time, for all of eternity, if you're looking for an X intercept, the Y value is 0. So if you were to plot an X intercept, that means it's going to be on the x-axis, and you can pick any point that you want to. These are your notes, so you can pick any point. I like 3. 3 is my favorite number, so I'm going to put it here at 3. That point is 3, 0, because it has an x value of 3. It went over 3 from the origin, right 3, sorry, and then up 0. That's it. That's an x-intercept. And then for a y-intercept, the y-intercept is on the y-axis. So that means that if it's on the y-axis, then we didn't go left or right any, we just went straight up or straight down, which means that the x value is 0, the opposite value. So whatever you're looking for, it's the opposite value that is 0. So you can pick any point. Again, I like 3, so I'm going to do -3 this time. That means we went over 0, down 3. And you can pick any point. So that's all. That's what it looks like. And then as we apply this a little bit, if we're looking for the x-intercept, if we're given an equation and we're asked to find the x-intercept, then we know what you want to first do is write down what you know. What do you know about an x-intercept? For something to be an x-intercept, the y value is 0. So that means that whatever the x-intercept value is, the y value had to be 0. So I'm going to plug that in for y. Simplify. 4 times 0 is just 0. So I don't really need to write 0. You can if you want to. But in this case, it's not really relevant. I mean, it is relevant, but you know what I mean. It doesn't change the equation necessarily. And then solve for x. So it's 3 times x, which means we're going to divide. And we get 4. So the x value of the x-intercept is 4. If I were to write that as a point, that would be 4, 0. And I could do the same thing for the y-intercept. It didn't ask for that in the notes, but you could plug in 0 for x, solve for y, and you would have the y-intercept. With those 2 points, you could draw the equation of the line, but I'm getting ahead of myself. We're just looking at intercepts. Okay, over here we have a nonlinear function, which we will study later. But we can go ahead and find the y-intercept. It's a simple process for this one to find the y-intercept. What do we know about y-intercepts? We know that the x value has to be 0 in any type of function, doesn't matter. So I can plug in 0 for x everywhere that you see an x. Simplify. 0 squared is 0. 5 times 0 is 0. 3 times 0 is 0. And then add 0 plus 0 is 6. So my y-intercept is 6. As a point, sorry, the y value of my y-intercept is 6. So as a point, that's 0, 6. And that's all. That's all you have to do. And that's how you know it's a y-intercept, because the x value is 0. This is how you know it's an x-intercept, because the y value is 0. So I mentioned earlier that we would be looking at tables. I don't have an example with tables in here, so I just want to quickly show you what that would look like if you were given a table. So let's say you're given a table, you've got x values and y values. Usually I orient that differently. I do a t-chart instead, but it's okay. It's the same thing. Okay, I filled in a table of values based on this equation actually, which you don't have to know how to do that yet, but you can just copy down the table of values. And so that way, if you are given a table of values, you'll be able to know how to identify where the x and y intercept are. So we already know that for x and y intercepts, we're looking for 0. So that's going to be the thing that catches your eye. If you see a 0 in a table of values, then it's going to be important. So I'm going to go ahead and highlight those. Here's a 0, here's a 0. And then I need to decide what each one is. So for the first point, 0, -3, if the x value is 0, then that has to be a y-intercept. And then for the next one, the y value is 0, has to be, we're running out of room. Nope, I'm not. And x-intercept. So those should stand out to you, the zeros. And then once you see the zeros, you should be able to decide, okay, what is it? Based on what I know, what is it? And that's it. That's all you have to do for a table. You just find it, list it, the end. And then the last representation here, we have a graph, and we're going to be stating the x and y intercepts. This is a non-linear function, but we can still find the x and y intercepts just by looking at the graph. So I want you to pause it, write these points as a, or they are points, write them as a point, and pause it, try it, come back. Since this one is non-linear, we call this a, this is actually quadratic, we call it a parabola. It is crossing the x-axis 2 times. So we actually have 2 x-intercepts. One is at -4, 0, and one is at 2, or 2, 0, sorry. And then it has 1 y-intercept. It crosses the y-axis 1 time. And that is at 0, -3. And that's it. That's all you have to do. So that's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help, and I'll see you in the next one.